Welcome viewers. This is my seventh lecture on GATE 2021 series, which our college, Prestige Institute of Engineering Management and Research, has started. And this series in continuation with the further, uh, is in continuation with the last lectures which I am taking of section number 2, Applied Mechanics and Design, and module is Engineering Mechanics. As you have seen in my previous lectures that myself, Professor Hemant Sharma, I am teaching in Department of Mechanical Engineering and in a famous college of Indore, Prestige Institute of Engineering Management and Research. My qualifications are as under. I am pursuing PhD in Mechanical Engineering from DAVV Indore. I have completed my various degrees like ME, MBA and BE from SGS ITS Indore, and I have qualified the GATE examination 4 times, 2010, 11, 12 and 2020. As you all know that the syllabus of engineering mechanics as per the GATE 2021 is the various parts are free body diagram and equilibrium, process and frames, virtual work, kinematics and dynamics, impulse and momentum. I have started the process and frame parts, and in my today's lecture, that is lecture number 7, the various content which I will be covering are the numerical portions on beam and to find the support reactions. Before going further, starting my next PPT, I request you all viewers and students to please subscribe my channel and press the bell icon so that you can get the notifications of my next upcoming lectures. Let us start with question number first. That is for the question number 1 is the simply supported beam with point load. As you all can see in the shared slide that in the question, the beam AB is given, which is of 4-meter length, and the from end A at 2 meters from the end A, a load of 12 kilonewton is applied downward, because of which the reactions at A and B will be occurred. At A point, the reaction upward will be RA, and at point B, the reaction will be RB upward. Now, we are going to the solution part. As you all know that equilibrium conditions, you all know in previous lectures I have discussed that the summation of F is equal to 0, and summation of F means the summation of all the forces on any body will be equal to 0 at equilibrium condition. This means that all the horizontal and vertical forces components will be equal to 0 in 2 dimension. Here only there are the vertical forces, therefore we are summating V is equal to 0. That is vertical summation of all the vertical forces is equal to 0, taking F means force downward as positive and upward as negative. I already explained in the last lectures that sign conventions are the conventions with the help of which we are able to solve the numerical. So sign conventions you can take either way. If you are taking force downward, then the upward force will be taken as negative. As per the conditions we have mentioned above, sign conventions, the the downward force is 12 kilonewton, minus sign, upward is reaction RA, and minus sign upward, because upward reaction will be RB at point B, and that three forces are acting on the whole beam, taking the signs as per the sign convention which we have mentioned, that and equating equal to 0. So we will get RA plus RB is equal to 12. I have not written the unit. It is understood that RA plus RB is equal to 12 kilonewton. The significant meaning here gives you the that impression that RA plus RB, the reactions at A and reaction at B, is equal to 12 kilonewton. Now switching further to the next part of the solution. At equilibrium condition, you all know that summation MA is equal to 0. That is summation of all the moments at point A is equal to 0. So here the sign convention taking moment downward as negative and upward as positive. Because I already mentioned in my previous lecture that the force which is downward, which will create the moment upward. Therefore, the sign conventions of force and moment are reverse to each other. Therefore, we are taking the moment at A point and equating to equal to 0. Then RB into 6. The moment of the reaction B at point A will be RB into 6 because it is at a distance of 6 from point A. Minus sign because this is upward, therefore the sign is taken as positive, and 12 kilonewton force is downward, therefore sign is taken as negative, and this 12 kilonewton force is at a distance of 2 meter from point A, therefore the moment created by 12 kilonewton will be 12 into 2, that is equal to 0 because the sum of all the moments at point A is equal to 0. Therefore, solving this equation we will get RB is equal to 4 kilonewton exactly, and substituting the value of RB in equation number 1 in last lecture, not in last PPT, we get the value of RA is equal to 8 kilonewton. So students, here we are able to find the reactions at point A and point B. As you all know that here the question in this question, the RA comes out to be 8 kilonewton and RB comes out to be 4 kilonewton. The interpretation part is that the 12 kilonewton force is applied downwards at any point. Then, as per the question and solution, we get the different reactions at point A and point B. The whole force acting downwards as 12 kilonewton will be divided into two parts. Into two parts, the first part is at A, which is the reaction upward and equal to 8 kilonewton, and reaction B upward, which is equal to 4 kilonewton. Okay. I hope that you have understood the question number 1 solution, and now switching on to the question number 2. The question number 2 is the simply supported beam with uniformly distributed load. In short, you can write it as UDL. What is the UDL? As I have already mentioned in the last lecture number 6, that UDL is the uniformly distributed load from one point to another. As you can see here that B is the beam whose length is 4 plus 2 plus 1, 7 meter, which is supported at point A and point B. Therefore, reactions at point A will be RA upward, and the reaction at point B will be RB upward. And there are 2 points. One point is 2 meter from distance of 2 meter from A, and another point is 1 meter left from point B. And the uniformly distributed from one point to another point, that is at a distance of 4 meter. The uniformly load is distributed from for 4 meter from this point to this point, and the uniformly distributed load is of 7 kilonewton per meter. So when we solve this question, first we have to find out convert the UDL to point load. As you can see in my next slide, the solution part. First, convert UDL to point load, and the UDL will be always acting at the center of the from the span, center of the span. That is from this point to this point. If the uniform load is of 7 kilonewton per meter is distributed over the span of 4 meter, then exactly at the 2 meter from both the sides, at 2 meter the centrally that there is a center point, and at that point the UDL concentration of the UDL will be pointed toward the center. So converting the UDL into point load, the point load will be equal to 7 kilonewton per meter distributed over the 4 meter span. Therefore 7 into 4, that comes out to be 28 kilonewton. Okay. Now moving forward toward the next part of the solution, that the equilibrium condition says that the first part is all the summation of all the forces equal to 0. Here there is no horizontal force, only the vertical force is acting. Therefore, equating all the vertical forces, summation of all the vertical forces equal to 0. Sign conventions, as per I have mentioned, the force downward will be taken as positive and the force upward will be taken as negative. Therefore, UDL 7 kilonewton per multiply by distributed over a span of 4 meter. Therefore, point load equal to 7 into 4, that is 28, minus, and downward, therefore sign is taken as positive, minus RA because reaction is acting upward, minus RB, reaction at B point is also acting upward, equal to 0. So the RA and RB, the summation of RA and RB comes out to be 28 kilonewton. This is equation number 1. Now moving forward toward the next part of the solution, that at equilibrium summation of all the moment at any point equal to 0. Now equating the moment here at point A equal to 0 and taking the moment sign convention as reverse of the force. So upward moment will be taken as taking moment downward as positive and upward will be taken as negative. So at point A, the moment due to reaction B will be RB into 7. That because the formula of moment is force multiplied by perpendicular distance, minus sign because the 7 kilonewton force is acting downward. It is UDL, converting it first into point load, that is 7 into 4, multiply by the distance of the UDL. When converted into point load, its center will be, as you know, that center comes out to be at the middle of the span, which is 2 meter, and further 2 meter from the A point. Therefore, total distance comes out to be 2 plus 2, that is 4, equating equal to 0. Now, because the summation of all the moment equates equal to 0. So solving this part, we will get RB is equal to 16 kilonewton. Solving this equation and substituting the value of RB in equation 1, we get RA is equal to 12 kilonewton because RA plus RB is equal to 28 kilonewton. Therefore, the interpretation part of this solution will be when the load of a load of UDL 7 kilonewton is acting downward as shown in the figure, and the converting into total load, that is point load 7 into 4 28 kilonewton, total load is acting downward, then the reactions at A point will be 12 kilonewton and the reaction at point B will be 16 kilonewton because the total load will be distributed in two reactions, that RA, that is RA and RB. The values of both will be different, may be different, and comes out to be the value comes out to be after solving the as per the solution which I have mentioned. Okay, I hope that you understand both of these conditions. In my next lecture, I will be discussing simply supported beam with uniformly varying load. So please watch my next videos. Thank you.